All righty. Welcome everyone in the classroom. Welcome everyone out in Zoom. Today we have a lecture by Siva. Siva comes to us from EPRI, and Siva will talk a lot about how we can approach multifamily buildings, especially how we transform them into grid interactive buildings. And Siva comes to us from EPRI, Electric Power Research Institute, where he's been managing a lot of R&D projects and knows a lot of cool stuff. And so without me talking much more, I'm very excited that Siva is in person here. And so he can talk to us and we can hunt him down and get him going. All right, Siva, without further ado, please come up to the stage. Thank you, Zoltan, and take it away.
All right. Thank you, Zoltan. And thank you, everybody, for joining. Wanted to talk to you about, when Zoltan approached me and said, when he's running a class on occupant-centric approaches to grid interactive buildings, and I said, okay, that sounds interesting because that's kind of what we do in EPRI. At least our research is focused on how do you include the human element into the overall research component so that you can get better outcomes with that. So today's talk is focused on how we take this customer-centric approach or approaches in general to transforming multifamily affordable housing communities to GEB, right? So multifamily itself is interesting, but multifamily affordable housing is even more interesting. And we'll talk about why that is the case. Sure. Oh, no worries. No problem. Okay.
Back to business.
Yeah, we're back to business. All right. So let's talk a little bit. I want to provide a basic outline for the lecture. We want to talk a little bit about some definitional elements. What is customer centricity? That's in its own right is important because if different people have different definitions for it. What are GEBs? How do you define it, right? That's important. And then motivation for this, right? Why is customer centricity important, and why is it important in the context of multifamily affordable housing? Then we walk through some examples that motivate from our research, talking about some lessons learned in doing this research, and then take some use cases. And if time permits, I'll just walk through an example of one of our latest projects that we're working on. I do want to get to the front part first and make sure that we have enough time for that. So let's get through some basic definitions. Let's talk about customer centricity as defined by the research that we do. So the solution is considered to be customer centric if it places the customer, quote unquote customers need front and center. That means that however broadly you define the customer, their needs have to come first. It's not the technology that drives the solution. It's not the utility that drives the solution. It's not the power company. It's not the grid. It's not anything. It's not some amorphous entity. It is the people in the community that it's serving, that is their interest that's driving the solution first. That's number one. Number two is, if you think about it, it's driven by the sense of empathy. One has to put oneself in the shoes of one's beneficiary so as to be able to understand how the solution can work best. And then, but also from an economic standpoint, it's a market-driven perspective. So it's not just the fact that you are, taking a bunch of people, asking them, hey, what do you want? And then giving it to them. It is from an economics perspective, it's market driven. And that's the what, right? So the why is that we have to understand that the energy ecosystem serves the customer in the context of their community through a utility or a service provider. So think of this three-party, this tripod, right? You have the customer in the middle that's served by this in their sort of community, that's served by this service provider. So any solution that you're going to have, if it can provide positive outcomes for all three of these entities, that's the solution that you really want. And now one thing that, again, anecdotally, what we've observed is that, you can go and you can preach and you can kind of try to change people's minds into doing more energy conservative behaviors and things like that. But what happens is that may or may not give you all the things that you're looking for in terms of the overall solution efficacy. But if they don't do something right, then it's going to impact the solution terribly, right? So the negative impact of them not doing something impacts the overall solution. And we'll talk to some examples of that as well. So sort of keep this in mind, keep this context information about the fact that we are working with this three-party system, and the fact that customers are the ultimate beneficiaries of this exercise, right? Okay, so let's talk about GEBs. What is a grid interactive and efficient building? It has to be a building first, okay? As stupid as it sounds, you cannot just have a parking lot, which means that, a lot of people have, you can do a lot with the parking lot. For example, you can make it all electric vehicles and you can bid that entire capacity into the grid and you can make a lot of money out of it. That's not what we're trying to do. We could potentially use the parking lot in the context of a building and do something with it. That maybe is okay, but it has to be a building first and has to be efficient second. All right, oh, okay, great, thank you. No worries. It has to be efficient, and that efficiency definition comes from standards, right? And standards and codes. So ASHRAE 90.1 standard or IECC code, that drives the efficiency standard. Third thing that is important is you need to have some flexible loads, and by that we mean loads that can be controlled through a control system. So you need to have flexibility, and so you need to have things that can be flexed and things that flex it. So the flexible loads and the control system. And last but not least, and this is something that, again, is part of the research that we do, is it needs to employ a principle, sort of good design principle. A good design principle is something, again, if you go back to that tripod, the three-legged stool of customer, community, and the utility, it has to provide a solution that can work well for all three of them, positive outcomes for all three. What is nice to have could be things like electrification, which means that your end-use loads could be electrified. Again, this is not going to work every single case, right? You may not want to electrify everywhere, and depending on how well that electrification solution works. So it's not a given that these grid interactive buildings have to be electrified. The second thing is on-site renewables. Again, depending on where you are, may or may not be the right environment. In California, for example, you are highly discouraged from putting on rooftop solar. Why? Because you have an overabundance of solar energy in the middle of the day when the loads are low. So when the solar turns off and you come back home and you turn on your air conditioners or you plug in your electric vehicles, when there is no solar, you now have a huge gradient between where you are to where you need to be. And that ramping requires a lot of peak power plants to be kicking in. And so the carbon emissions at that time is very high. So if your goal is to decarbonize, on-site renewables with solar in California is not the right approach. Third thing is compensation. May or may not involve compensation. Again, if you're going to inconvenience somebody for them to flexing their loads for a greater cause's benefit, then you may want to compensate them. Again, it's not required, but nice to have. And then it's also nice to avoid a bad design principle. A bad design principle is one where you're taxing one entity of these three adversely so as to provide much better outcomes for the other two. Again, it's in an abstraction, it sounds weird, but we'll talk through some examples of that as well. So yes, that's the definition. So let's talk a little bit about multifamily and why it's hard, right? So there's two reasons why multifamily affordable housing transformations are hard. One is motivation, and another is economics. The motivation is that, I don't know about you all, but when was the last time you thought about how much energy you're using on a day-to-day basis? You probably are thinking a lot because you are in Zoltan's class. But not everybody does that, and the average consumer does not. So asking them to think about something that they are not motivated to think about all the time is challenging to start with. Secondarily, if you are living in a multifamily community, the operator, the builder of the community needs to have a certain motivation to go and make the changes, make them more energy efficient and so on. Even if they were motivated, they are faced with a lot of choices. Do you put a heat pump? What kind of heat pump? There's like 50 different providers of heat pumps, water heating versus space cooling, space conditioning. Do you put electric stovetops, or do you put gas? All of these are economic decisions that they make, and they have these choices, and it becomes a big challenge for them. And then last but not least, these multifamily affordable housing, remember the beneficiary here is the customer, right? Is the person that's living in these communities, but they are renters, so they don't get a choice in what air conditioners they have at home, or what sort of heating systems they have. They could go and put their own sort of little space heaters and so on, but they're doing that out of their own pockets, not necessarily what's provided by the community. On the flip side, on the economic side, the first cost, as is the cost that you are spending right up front to make these changes, are very high compared to the standard products out there. So that's a big challenge. It's the inability to recover that cost. So if you're going to invest in it up front, you may want to, a good way to recover that cost of investment is to make sure that your cost on a monthly basis is lower. So if that can potentially work out in your favor, then it's great. But some of these technologies are not quite there yet. And then, of course, you have lots of incentives out there. For example, through the infrastructure law or through Inflation Reduction Act type of initiatives. There's a lot of incentives that are available, but there are also other incentives that are available for putting on rooftop solar and things like that. But sometimes these incentives are mismatched. They're not necessarily serving the right community. Meaning, if you have the money to go and make the investment in putting on solar, then you'll get a nice incentive for it. You get incentives for owning an electric vehicle, but if you are, if you're going to make a choice between putting food on your plate or actually buying an electric vehicle, you're probably going to be spending money for buying food, right? So those customers are not going to get incentives for going green, so to speak. So there's a lot of choices, and there's a problem, and this is one of the challenges that we have with multifamily. But let's take a little bit of a deeper dive into these factors on the motivation side. Here's a little survey that was done by the Federal Bank of St. Louis. I think it was done in 2022 timeframe, where they asked people, what are the negative impacts in low and moderate income communities? What is causing the sort of issues? What are the big things that is keeping them up at night? Number one on that list, not surprisingly, is generational poverty. They're worried that they are living in poverty, and their children are also going to live in poverty, and their parents live in poverty, and so on and so forth. Availability of jobs, job skills, education. As you see, energy is not even anywhere here. It's the cost of energy. None of these things. They pay a lot for their energy, but it's still not in their mind. So this is the big challenge that we have. So to ask them to be more energy efficient is not going to work that well unless you actually do something very active with them. And the energy burden that they face, on an average, people living in multifamily communities face about 3.5 times higher energy bills than people who live in multifamily communities. Multifamily affordable housing pay 3.5 times more than ones that are on a per capita basis than those that are living in multifamily, and it's 45% higher for them. The energy burden, as we call it. On the flip side, that's what the customers are facing, and then on the flip side, you have what is being faced by the operators themselves, these owners of these buildings. They are now making choices when something is broken. Do you go and fix the insulation to make the building more insulation tighter and make it more tolerable in cold weather? Or do you go and change your heat pump system, or you go and put on solar? What do you do? And there's all these choices they are faced with, and they are not energy experts. They don't have Energy Plus or anything of that sort in their readily in their hands to do this work to understand what's going on. So there's a energy burden, and then there's choice burden on the part of the affordable housing providers, and they are kind of having this perfect storm situation. And then, of course, here is an example of a recent analysis that we did for a set of communities in Seattle. So the names of the communities on the left are, these are actual multifamily affordable housing communities. There's a total of about 300 living units across these communities that we looked at. And if you look at it, it takes about $3 million to do everything that is needed in these communities, right? They need air sealing improvement. The buildings are not very, tight in terms of their envelope, so you need to improve air sealing. You need to add some heat pumps, some centralized heat pump water heaters, add some solar PV and some GEB controls. And if you did all of that, you get about $102,000 a year out of it. Remember, these changes that you're putting in, the solar PV, the water heaters, and so on, they have an average lifespan of about 18 to maybe 20 years. Whereas with this economics, even if you did not do any discounting on the future value of money, of the $102,000 that you're going to get, you take about 28 years to recover the cost. So that's a big challenge. So normally speaking, and this is an environment, by the way, this is in Seattle, where the grid electricity is 97% carbon-free because it's all hydropower. It's great, right? And their economics are also really good because they pay about 7 cents a kilowatt hour, whereas for a therm of gas, they pay about $1.20. So there's a huge disparity there. And in fact, you're discouraged from going and using gas. So they are encouraged to use electricity. And for them to be doing something, so they're electrified communities and they are now adding all these extra stuff to it. You're making it more efficient, and it still takes them this much longer to recover the cost. So this is an environment where electrification is a given, and you still have trouble recovering the cost. So this is the problem that they face. So if you take into account all of these things, we can now come up with what we call the requirements for how do you make these GEBs more customer-centric, right? So if you want to make these GEBs more customer-centric, the first key that you have to do is to protect the bill, meaning make sure that whatever bills that these customers are paying after the fact, after your upgrades that are done, is less or equal to at least what they were doing before. So they cannot have a higher bill. And if they did, then it has to be with their consent, right? It has to be moderate and it has to be with their consent. Residents of these communities may not be tech savvy, so that's important. However, the access to technology is really important, because all of these newfangled technologies that you're seeing have a certain tech savviness that comes is taken for granted. And if these customers don't have that, then we have to spend the time and effort to teach them how to use it right. Broadband access is a huge problem. All of these are connected communities. You need to have broadband access. You may have Wi-Fi, but you may not have broadband. So if that's the case, then yeah, you're going to have trouble. And then, so the customer education and engagement is important. And then last but not least, taking into account customers' input in all of the solutions that are being developed or in designing these engagement programs is also important. So taking into account all of these requirements, we can start designing an ideal sort of GEB solution, so to speak. So here are some lessons from the past. Now, we took these and we started doing it piecemeal, right? We did one and then trying to do the other and trying to do the other and so on. So let's look at some examples, right? So here is an example. These are two communities. The community on the left is one that was in Southern California. The community on the right is one from San Diego. The community on the left is an example of how to do this correct, so to speak, right? Because what you're trying to do on the left-hand side is there is a period of high time of use rate during the middle of the day between 4 p.m. and 9 p.m. And you're trying to reduce energy use at the time. So we used a combination of messaging to the community through an app, and then solar and storage. So you flex the solar and storage, you flex the battery in the community, and then you can see how you're able to get reduction in energy use during this period of time, but then it shifts the energy use ahead of time. So this is actually good because this is the time when solar is available. And so it's great. You're just using a little bit more energy at the time, whereas you're using a lot less energy during the time when 4 to 9 p.m. So the bills are lower for this community. So this is great. So that's a good example. On the right-hand side is a community where we went and we added in San Diego, where we went and added water heating. This was, we took a bunch of, this is a 192 apartment community in San Marcos, California, in the San Diego County. And if you are, this may be news to you, but in San Diego County is perhaps the highest in terms of energy rates in the country. You pay close to $1 a kilowatt hour during the 4 to 9 p.m. time frame. It's in this time frame. And outside of that, it's still not that cheap. It's like 45 cents a kilowatt hour. So it's the average cost is about 12 cents a kilowatt hour across the country. So this is 4 times as expensive to pay for energy in California, in San Diego. And for them, when we went and electrified the water heating, we saw a significant increase in bills. So as you noticed, especially in the cold months, the reason for the cold months is because heat pumps are not that efficient in the cold months, right? Your ambient temperatures are even in San Diego is lower than normal, and the sort of heat pumps that we were using are not sort of moderate climate heat pumps. There was a bunch of engineering challenges with this community as well, figuring out how to size the tanks and so on, right? So there's a whole surrounding set of engineering challenges that go with it. But suffice to say that if you compare just the electricity cost from before to after is huge. But even if you take the total energy and you compare it to the after, it's still high. So we had to then figure out how to reduce the energy bills in this community. So this is an example of how sometimes you have the right intention, and yet you're not able to get the economics right. The only thing correctly that we did in this community on the right-hand side is that there was enough incentives for the entire community to get all of the electrification done at zero cost. So the community had close to $1 million available for making all these changes through incentive programs in California and through the incentives available through San Diego Gas and Electric. And yes, they paid nothing out of pocket, but at the end of the day, they were paying in the operating cost. So that's a challenge. Yeah. Yes. So this community, in fact, one of the solutions that came up, and one of the reasons why this is so high is because they were slow in getting solar. They had just solar PV in the community put on that could have been that could help to reduce the energy cost, but they didn't have it PTO'd by then. The permission to operate was not granted yet. Once, I think around June timeframe is when it kicked in, and you can see a dramatic reduction in. But nonetheless, you have to do more things now on top of what you did, and the community had to pay for it.
Because the gas bill goes away for heating, right?
Correct.
But it was not this high.
No, it was not. Yeah, exactly. All right. Here is an example of misplaced incentives. And this is an analysis that we did for Austin Energy here in Austin. And so here in Austin, if you have this is a model scenario. We used Energy Plus to model a single home. It's like 2,500 square feet home, where you had gas appliances and you replaced the heating and air conditioning with a heat pump and a heat pump water heater. And the x-axis is the cost savings on an annualized basis that you can get out of it. And the y-axis is the carbon and is the CO2 offsets that come with it, right? So you're basically stopping all the on-site fossil fuel use, so that reduces your CO2 emissions from the building. But so that's nice, because on the y-axis it's low, but on the x-axis your cost savings are also almost zero. So you're not gaining anything by switching to electric, right? Your cost structures between your gas use and electric rates are not favorable enough to make that switch. Whereas if you went with an electric vehicle, you actually can get a lot of carbon offsetting, because you're not only offsetting the carbon at home, but you're offsetting all the gas, all the CO2 that you have emitted in the process of driving the vehicle. So that helps. And you get a moderate cost gain, savings of less than about $500 a year in gas costs can be avoided as a result of that. So there's a little bit of advantage there. But notice something here, right? These are your flexible loads. Right? These are the loads that you can flex, your heat pump and the heat pump water heaters. You can't flex your solar for sure. And even with solar and storage, solar with storage and without storage still give you the same cost benefit, right? And so it makes absolutely no sense to go and put a battery in this community. There's no sense in putting heat pump and heat pump water heaters from a flexibility perspective, right? So what are you really gaining out of all this? Now, there are incentives for all of these things. There's incentives for battery, there's incentives for solar, there's incentives for heat pumps. The only real incentive that works here is for EVs. So here's an example where your incentives are misplaced. So when you have these misplaced incentives, you have a challenge. So we need to figure out how to get this situation right. And then last but not least is user, how are users impacting the whole thing, right? So this is a community where it had an old swamp cooler, these big fans which have like water going through them and basically blowing cold air in the that's your cooling that you get, and a gas wall furnace. And these are really old ones which we are replaced with a heat pump. But because the community didn't have a whole lot of electrical capacity, we couldn't go and replace it all with these, the regular market-ready products. So we had to put in a 120-volt system, which is great. The initial cost was much higher, but you can see that the average energy use is not bad. But look at this, while there's a band of users who are using it in this close to the average, there are a few stragglers who are using it all the time and they're not using it that well. So this is a 24-hour profile, an average energy use profile. And in this one building alone, you can see how there are some users that tend to use it more conservatively and ones that are not using it conservatively. So now here is an example of how educating these customers about their energy use could be useful, because it's after all their electricity bills that are going to be impacted in this process. So here are some good examples of how customer-centric approaches can potentially work, right? This is an example of how this is actually using OhmConnect. We worked with OhmConnect in California in a community where we went and added solar and storage and load management and added OhmConnect as a platform for messaging customers. And this is the same example that we showed earlier. I think I had an example on the left-hand side. So this behavior actually is related to this. So if you think about what you saw there, the load shifting behavior there, that was for the entire community. This is specifically to the participants, the customers who are living in that community. And they, on an average, were able to get about, I think it was about 70% of those community was able to get that, something of the order of 70% energy reduction through this platform. So, and more importantly, all of this capacity, right, the reduction in energy use was being used to offset needs from the overall grid. So the DRAM stands for demand response auction market. This is a mechanism where capacity that is available by reducing loads at individual homes then can be taken, and that excess capacity can be bid into the market to reduce the need for going and building new power plants. So if you did that, you're able to see that there is a tremendous reduction and advantage to that participation. Normally, you get about 1 to 2% participation in the DRAM market, whereas you're now getting about 15%, which is great. So this need to talk to customers and basically educate them and then give them positive, value out of it. By participating in the DRAM and reducing the energy use, they get points, and these points can be redeemed for things like, gift cards for a grocery store or for Amazon or whatever, right? So this is real money that they can actually use, this community can use. So they actually like participating in it, and they do that well. The second example is when we went and upgraded the community with a whole bunch of efficiency and heat pumps. Before we did the upgrades, we asked them, hey, what's your big problem here? And they had three things that they were problematic for them. Two of them related to lighting. The community was too dark, they said. And then they said, one of the things they said was, the air is a little dirty, right? They didn't quite relate to the fact that air being dirty is a function of the fact that their HVAC system is not great, right? They are, because this is where the disconnect happens. They don't quite understand the causal relationships between why something is happening and what they are able to do to make it better. Whereas, okay, so that is what you saw before we went and upgraded the community. And after upgrades, here is what we find. We find that the number one thing that they loved about the upgrade was the windows and the sliding doors. Why? Because you have less noise. We heard anecdotes like, I cannot hear my quarreling neighbors anymore. Right? This is great. So it's a simple double pane window, and all of a sudden, it's great, right? The people are actually able to open and close the sliding doors. What a great idea, novel, right? So that was awesome. And HVAC, of course, was number two, but still. And then on the list of all of the favorite measures, refrigerator was number one. So why? Because they had a broken fridge before. Anytime they would buy groceries, within a week or less than a week, it'll all go bad because the fridge was not working well. Whereas now we had a working fridge, great. The cooking range, we replaced a coil cooking range with a glass top. Now they're able to have a clean cooking range. What a novel idea, right? So these are the kinds of things that happens, but why is this important? This is important because if people are happy with what's happening in their homes as a result of the upgrades, they'll start thinking about what else they can do to make it better. Right? The idea is to motivate them the right way to get them to do this well. And then we can start thinking about, okay, now that we have some of these anecdotal evidences, how do you develop an approach to quantify these things? So this is important because at the end of the day, Austin Energy or any of the power companies out there that are trying to do this and trying to make a change and helping the communities do a better job. Again, going back to the tripod, right? You have the customer within the community served by the service provider. So it's the service provider that is doing the things that can help these communities. So what can they do to help? And how can they do it in a way that is meaningful to all three of these entities, the customer, the utility, and the society, right? So to do that, you have to go through a sort of a systematic approach to it. You understand what the costs are. What is the cost to the community? What is the cost to the customer? What's the cost to the utility? And then you figure out what the benefits are. What are they gaining in the process? Are the customers seeing a reduction in bill? Is the community seeing a reduction in GHG emissions? Is the utility seeing some sort of economic benefit out of it? And then you start looking at what the primary value dimensions are and what the trade-offs are. So you can say, hey, you know what? Austin Energy is going to start this new program where they're going to do energy efficiency upgrades. They're going to spend X million, and they're going to get this much GHG reductions as a result of that, which satisfies the needs of some climate action plan that the city of Austin has, right? It's great. In the process, the customer is also going to save, on an average, $120 a year. Great, even better, right? So if you're able to do that, then the fact that they are investing in that X million is useful, right? It's tax money that's being invested. So now you have a good way of understanding the trade-off between investing the tax money in those programs versus doing it in something else, right? So that sort of trade-offs can be better understood, and you now have a better way of understanding the whole thing. If you went through this exercise, and you associate a computational model with it. And the reason I'm bringing in the computational model is because I am talking to students, and this is kind of something that is understood by students, right? I mean, you guys understand how to compute costs, how to do energy plus modeling. If you do that, if you take the first cost and the operating cost, and you start doing this computation, and you run through this analysis and this model, and you get the results, here is what you get, right? In the multifamily community. So this is in Seattle. Again, one of the better scenarios for electrification and efficiency upgrades. And you see that you have either options for 120-volt systems or options for regular 240-volt systems. There's a price differential on the first cost for it. There is similar returns on the operating cost. The incremental peak demands on the distribution grid are also somewhat similar, and you're seeing similar returns. So clearly, the 120-volt systems they do better. The economic value arising from these heat pumps and heat pump water heaters and space conditioners could be used in this community. So this community is ripe for making that sort of investment, right? So, okay, now that we've talked about all of this, yeah, we have enough time to go through this. Let's talk a little bit about what we are doing with all of these learnings, right? So here is what we did to recap before I get into this scaling up business. All that I've shown you are one-off examples, right? Anecdotal evidences. So you can, I would not be surprised if you were to say, hey, Siva, great that you showed all this one-off examples. You took this one community in Southern California and you did this cool thing with that. It cost you $3 million to do that, and great, fantastic. How do I do this everywhere, right? Because ultimately, of course, what we need to do is to come up with a mechanism to scale this across the country, across the footprint of buildings. It's not important, it's not as important to do it on a one-off basis. Even regularly speaking, right? I mean, if you look at your cross-section of articles that I see on LinkedIn and so on, there are lots of people that talk about how heat pumps are useful in Wisconsin. Yes, you can do for that one home. Yeah, it works really well. Yeah, because they did a lot of things to go and use that heat pump, put it there, but also they did a bunch of things and made sure that they were on top of it. So if you did that, that approach doesn't necessarily scale in the sense of being market transformative, right? To be able to scale, the first order of business is it has to be simple so that everybody can actually understand it, right? And it has to basically involve them doing less and getting more. So the question is, you take all of the lessons learned here, how do you use that to develop a system that can scale up? So here is what we finally decided to do. We decided to develop a project where we said, enough is enough. We're not going to do it in one-off communities. We're going to take a cross-section of communities. Okay, sorry. Yeah, so I'm going to take a cross-section of communities. I'm going to, first of all, do this demonstration project across two different climate zones, right? Pacific Northwest and New York. Pacific Northwest is important. Why? Because that sort of represents an ideal scenario. Low carbon emissions on the grid to start with, better rates. Again, all of the reasons why I said Seattle is great for doing electrification comes into play. But don't do it in one community, do it in 6 communities. So what I showed you earlier, I think I had a graph here that showed how it takes 28 years to recover the cost. What I did not tell you is that it takes 28 years if you did nothing, literally nothing with grid interactivity, right? This is purely from efficiency. The grid interactive and efficient buildings, the grid interactive piece is combined with the efficiency piece to get your benefits. So if you now started flexing the loads, in addition to this, you will start potentially seeing some increase on this side. And I did not apply any of the incentives to this on the reduction of the first cost. So there is potential for first cost to come down. There is potential for this to go up. And again, the incremental peak load, the reason I brought up the incremental peak load and I added it here is because all of that peak load is shiftable, right? That is the extra peak load that's being added as a result of the electrification that's happening in the community. So if you're going to add electrified end uses and you're going to cause an increase of 12% in your peaks, you should be able to shave off that peak, right? With a control system. So now that brings along with it the ability to reduce your operating cost. So you should be able to now take advantage of that. So that is the secret that I did not tell you when I was talking about this, but that's what we want to do, right? We want to take those 6 communities and we wanted to add that as part of the demonstration. We wanted to demonstrate in New York because of 2 things. It's cold climate to start with, right? New York City is considered a cold climate environment. So heat pumps and typically have a problem with cold climates, and we need to now figure out if these heat pump solutions can really work. And the other thing is that we are working with New York City Housing Authority. New York City Housing Authority has close to 125,000 apartments, right? That's the size of a few cities in the United States in terms of their multifamily population of buildings. So right off the bat, you have a huge availability of scale potential here. Our demonstration is only impacting 300 living units. Even that is very small. But you now have the capacity to take the results of these 300 living unit demonstration and figure out from a model perspective what happens when you scale it across the community, right? So that's the idea here, is to take this demonstration, do it in these 2 different places. But on top of this, there are 9 other demonstrations that are happening across the country. So this is funded by the Department of Energy. This is their last big DOE funding. It's called Connected Communities. And EPRI is one of the recipients here of this Connected Communities grant. And we designed our grant to be doing this work in these 2 different communities. And ours is the only one that is looking at this from that broad perspective. We wanted to make sure that we included everything that we learned from our one-off demonstrations and the lessons learned into this. So we ended up incorporating elements of solutions that can basically encompass all of these, right? Heat pumps, heat pump water heaters, solar, EV charging, using grid marginal carbon emissions as a driver for doing this demand flexibility exercises, innovative mechanisms for customer engagement, multi-regional demonstration, capacity market participation, and local temporal congestion avoidance. Idea there is that you can take all of the capacity that you now have because of reduction in energy use, and you can bid that into the market. So that's one application. But you can also see that if you're able to reduce, if you're finding that there is a few points in your distribution network that is very heavily congested at certain times in the day, if you're able to reduce energy use at that time and shift it away from the time, you now have the capacity to not have to upgrade those resources. So that whole idea of temporal congestion avoidance becomes important. So if you did all of this, then you can potentially come up with a solution that can scale across the country, hopefully, right? So this is the idea. This project was kicked off in 2023. It's a 5-year project, so it's going on till 2027. We are in year 2 of this project, and we are doing a whole bunch of things. But the important things that I want to highlight today are, again, there's a big customer centricity to this, right? We are trying to do it in a way that is customer centric. And so what are the different things that we're doing here, right? So one of the things that we're doing right off the bat is customer education. So these 10 communities that we have across Seattle and New York, we are doing everything from little flyers that talk about what heat pumps are and what heat pump water heaters are, et cetera, to having these technology providers come and set up like little demonstrations, booths, and talk about what is going to go into their homes, because some of these heat pumps are going into people's homes, so they need to know how to use it right. So this customer education piece is very important. City of Seattle and New York Power Authority are both engaging in active customer engagement work. But as part of the engagement work, we are doing a lot of data collection from them, from these customers on their behavioral data collection, surveys, as well as data from their devices and their meters and so on and so forth. So getting them to understand how to do it right, and to getting all the data. And then we're also going through a rigorous process of getting it certified through the Institutional Review Board so that these customers are fully aware of what they're being, how they are being kind of impacted by this study. So here is one of the things that we did, right? In sort of, if you're going to design a program that's sort of directed towards a particular audience, you may want to know, right? What is the nature of your audience? Who are you targeting, your target market? So we developed a persona for these users, and across these communities that we saw, the average income of the household income in that community is less than $26,000 a year. It's terrible, right? I mean, I don't know if you, I don't think this is affordable in rural America, let alone in Seattle and in New York. But that's what people are. That's how much they are. They make in those communities. I think more than 50% of this community identify as people of color. Why is this important? Just from a demographic perspective, I think there needs to be, we need to understand the overall impact of things like environmental justice, racial justice, and so on in this community. Are we addressing the problem for the right set of people? It's important to know. There's food insecurity in this community. These community residents, they utilize email, Facebook, and the building community has a text messaging system that they use for different things, like typically for complaining about things that are broken, but nonetheless, they use it, right? So if they are able to use it for complaining, they could actually use it for getting some messages about how to use it better, right? They are composting in this community, at least in Seattle, and then the electricity is submetered for them. So this is important. In Seattle, these communities, the individual residents, they pay for their own electricity. Whereas in New York, it's master metered, but their electricity bill is sort of bundled up along with their rent. Some of them use some portable AC units. It's debatable. In New York, they all have these window rattlers, as they call it. They all, again, both of these communities, both in Seattle and in New York, the interesting thing that we realized was that they all have a great relationship with their building manager or their superintendents, as they call it. Again, because they do a lot of complaining, and these superintendents come and fix all of their issues at home, everything from broken faucets to whatnot. But they do have that relationship. So using these building superintendents as a vehicle for getting the message across to this community becomes a really important way of getting that engagement going. And we are also introducing a mobile app for this community. The reason we are doing this mobile app is because they are, remember we talked about this, they are not necessarily tech savvy, but access to technology is important. So if you're able to give them something that they already have and they use on a regular basis, if they're able to use Facebook, they should be able to use this app, right? Now, the question is, how do you make that engagement really, really meaningful to them? So we came up with a set of requirements for that. We wanted to, first of all, develop this innovative approach, right? We wanted to make sure that the platform does not assume that you have ubiquitous broadband, which means that you cannot use a desktop computer. You cannot assume the existence and presence of tablets and things like that. So the form factor has to be nicely represented within a small phone. Again, the phone generation has to be a couple of generations earlier. You can't assume that they all have the latest generation iPhones and Androids. You have to assume that the customers are capable of doing things like understanding how much they are paying for the electricity, right? But they do not understand things like kilowatt hours, right? Very few people actually understand kilowatt hours, but they do understand dollars, right? Because if they are using X kilowatt hours, it translates to $100 a month. They understand the $100 a month. bill. So talk to them in terms of what they know and not in terms of what what you're measuring. And then offer them the ability to kind of participate in these demand flexibility exercises, right? Is there a way for you to automate demand management for them, right? Bill reduction, can you automate it for them? And are they trusting you to do that? If they say yes, then you should empower them to do it, right? So use the app as a vehicle to opt into automatic load management, right? And then last but not least, allow them to basically reduce energy cost volatility. So the idea is that the thing that most of these folks hate is the fact that 1 month they are paying, I don't know, $50, the next month they're paying $100. That's a huge difference for them, right? And they would rather pay $50 a month and be happy about it and not worry about it. So if you're able to develop control objectives from the perspective of flattening their energy bills across the year, great. What does this all mean for us, right? So we are the developers of these solutions. What it means is that if you are confronted, first of all, with something like requirement number 4 that says they should be able to opt in and opt out of this at their will of automated load management. Now you need a mechanism in your MPC controls or whatever mechanisms or control algorithms that you're developing to take that volatility of participation into account. You cannot assume that people are participating at all times. So there has to be some of this stochastic nature built into your algorithm. Similarly, the energy cost volatility is important. And what does that mean? That means that one of your constrained control objectives is to make sure that the energy bill for the whole month doesn't exceed a certain dollar value. So, and that's typically a tough challenge, a challenging constraint, because it's not within your horizon of your MPC algorithm. It's not exercisable on every 5-minute basis. So there is a lot of challenge there. And so you now need to have a forecast that's kind of month across versus day across and shorter timeframes. So yes, it makes your overall control algorithms much more complicated. But if you're able to do it, then you have achieved a certain level of customer centricity. So here is what we did in terms of the app design itself, right? So we developed a bunch of screens in this app, and this app is going to be rolled out to the community at the end of the year. Right off the bat, we are giving them 2 options. We're giving them an option to set up a threshold for how much energy they want, how much bill they want to kind of consume on a billing cycle basis. These customers are billed on a bi-monthly basis, so it's like 2 months. And let's say that they want to spend no more than $195 for 2 months. Now, if you're able to tell them how much they have already spent across the 2 month, it's like $120 out of $195, then they can perhaps use that as a way to understand, oh, maybe I shouldn't be using, maybe I need to be more conservative or turning off the electricity, the light in that room that nobody is sitting in, right? So that's an idea. And give them some more information about it, more detailed information about it. Again, because this is bi-monthly, if you're able to tell them on a weekly basis how much they're using and correlate it to some aspects, then they can basically figure out what they did and to cause that energy increase versus decrease. Giving them information in the form of on a daily, weekly, monthly, and yearly basis, showing them some utilization pictures, giving them some actionable, meaningful tips on how to reduce energy use, right? It could be as simple as turn off lights in rooms where nobody is there. But we can also, for them, it may be more meaningful to say something like, make sure to keep yourself warm by, stay bundled up, right? They may want to do this rather than, at least towards the end of the month when they are getting closer to that $195, they may switch to doing that as opposed to turning on the heat. Now, as stupid as it sounds, I know, telling them to bundle up instead of turning on the heat is actually useful for them, because these are communities, again, that are $26,000 a year communities, right? These are not communities that have a whole lot of money to spend. So they'll be happy to do that. And then last but not least, giving them a simple mechanism to turn to opt in and opt out of controls, right? Just give them a single switch that says, I want to opt into thermostatic control. I don't want to opt into thermostat control. So if you opt into thermostat control, then we can exercise that control on a certain scheduled basis. If they opt out of it, then you cannot do that. So your control algorithm now has to be able to sense who's opted in and who's opted out, and therefore use that as part of the overall control mechanism. And here is the control architecture for this community. So we have, across the communities, we have a local controller, a local DERM system that is basically going to control the loads in the individual communities. And then that feeds into an intermediate building orchestration system called Sentient Neuro, which works with the DERMS that is part of the distribution network to basically receive signals from it and orchestrate it across these communities. We have a system of record for saving all the data coming out of it, and then a set of measurement and verification routines that can help understand what happens when certain control exercises happened, right? So that's the overall control architecture in this community. And then we have a set of coordinated control strategies, again, happening at 3 levels. You're happening at the individual unit level, at the building level, and across the buildings. We also have data coming out of these, and we also have levers for these implementing these controls. Inside the unit, it's driven by a mobile app and the DERMS. Across the buildings, it's at the building level, it's at the DERMS, and across the buildings, it's at the Neuro lab. All right, and the strategies to be deployed. I want to be cognizant of time, and let's just go and look at some of the takeaways. So yeah, right off the bat, we're facing a very complex situation, right? It's not an easy challenge for all the reasons that we spoke about. We are going to recognize the fact that this is a complex problem, and so it requires us to think a little bit more holistically and a little bit more systematically. We want to understand the trade-off that are there between user engagement, customer engagement, and automation. So this is important. The less you're able to require them to do things over and over, it's like the less you nag them, the better it is, right? If you're able to automate it for them, even better, as long as that automation can satisfy some fundamental requirements, like making sure the energy bill does not go up. And then we have to think through how to design our algorithms, methods, and systems that takes into account the fact that there's a customer-centric element here, right? That means what are the absolute must-haves, where are the nice-to-haves, and how do you trade off between those elements? That's it. I know I've left very little time for questions, but if you do have any questions.
So when we kind of ease the pricing, the energy bill that one wants, how do we guard against them being something that's not realistic that we can't possibly control? Like if we go like they propose an energy bill that's pretty much too low, that's you have control at hands.
That's a good question. So we start off with giving them how much is their average bills over the last year, right? Let's say the average bill over the billing period over the last year is $100. We would recommend them that they not reduce it by much more than $100, simply because of the fact that if that means that we have to be more aggressive with our controls. And we also make it very clear to them that if they do that, then there is no guarantee of being able to reduce the energy bills to that level, right? This is not a magical mechanism, so we have to provide, so our guarantees are only within a certain narrow band. Now, if these customers are truly, I wanted to show you one little thing here. So if you notice, We have what is called a UDP discount here, and these are customers that participate in what is called utility discount program. If their average annual income is less than a certain amount, they get about 60% off on the bills right off the bat. If they have not participated in that program and they are setting up their thresholds to be really low, then we will go and seek out to them and say, hey, you better participate in that program because that's automatically getting you 60% off. And now you can start thinking through how you can. The reason your energy bills is because you qualify for this program and you're not participating in it. Yeah, of course.
There's one question online that asks,
Yeah.
in the control architecture, do you have any difficulties integrating with legacy systems in the buildings?
Yeah, definitely. So one of the challenges is that the legacy system integration is a challenge. In fact, that's one of the reasons why we have that Neuro, because with Neuro, so Neuro has a mechanism that can basically work with a set of legacy through, they have adapters for that, typically through BACnet or through Modbus. So they directly hook into things like your thermostats and your HVAC systems, and they'll basically enable that through their own IoT adaptations. But yes, so it's a challenge.
All right, time's up. So let's thank Siva again.
Appreciate that. Thank you.
Class is dismissed. You all can speak. Thank you all.